Okay, and finally let's look at an example of a cyclic compound. This actually is benzene, six-membered ring with alternating pi bonds is known as benzene. And if we were to draw out our skeleton, we could show the carbons. This is a line drawing, so each of these junctions represents a carbon atom. It's a six-membered ring. So that means there's 6 carbons here with 3 double bonds. Okay, we have an OCH3 down here. And we have a carbon and a hydrogen. Okay, so that's our skeleton that we've drawn out, our basic connectivity. Now let's complete our Lewis structure. One thing that's missing here is with the line drawing. Remember, a line drawing, we're allowed to omit the hydrogens. We don't have to draw the hydrogens that are attached to carbon. So are there any hydrogens now we should fill in? Remember, every carbon wants 4 bonds. So looks like these 4 carbons on the ends here have only 3 bonds shown. So they all need an extra hydrogen. That was implied when we drew just the hexagon over here. So there's 4 hydrogens on the ring. And then how about this? These carbons don't have filled octets, so how can we take care of those and give them the 4 bonds that they need? How about adding a triple bond here? So we have that up here. And what's needed down here is just a 2 lone pairs on the oxygen to give it its filled octet. Okay, so hybridization. Before we do our 3D sketch, we need our hybridization. Our CH3 is sp3 hybridized because it has 4 regions. Our oxygen is sp3 hybridized. How about the 6 carbons on the ring? Every one of them has 1, 2, 3 regions, so they're all sp2 hybridized, trigonoplanar. In fact, trigonoplanar, the drawing we've already done is pretty much the 3D sketch. Is pretty much the shape of benzene. It's planar, and we have all those 120-degree bond angles. Okay, how about this top carbon? Has just 2 regions of electron density, so it's sp hybridized, and this other carbon is sp hybridized as well. Okay, so let's come down here and draw our sketch. So we can start with the ring. And as best we can, we'll just draw a nice hexagon. That would give us all 120-degree bond angles. There's a carbon and an oxygen on the top and bottom, and there's hydrogens in every other position. So as best we can, it really helps to do your 3D sketches in pencil so that if you realize you've drawn something that's not quite the right angle and you need to adjust it, you can erase it. It's tough doing it with a Sharpie marker, that's for sure. Okay, and what do our pi bonds look like? Our pi bonds are going to be p orbitals. So it turns out that with benzene, every single atom, every single carbon on benzene has a p orbital. So we could draw those in. They're all perpendicular to the plane. So just draw them all at the same angle because they're all parallel. And then here we're connecting these top 2 and these side 2 and these bottom 2. Something like that. Okay, how about our oxygen? Our oxygen is sp3, it's tetrahedral. So we draw it again with a little wider than 90 degrees. Now, because all we have are lone pairs here, we can draw those as a dash and wedge. But usually we don't refer to an oxygen as being tetrahedral, we describe it as being bent, because all you really describe for the geometry are the atoms, not the lone pairs. So comparing the carbon, oxygen, carbon, you describe that as being a bent shape. And then our carbon is also tetrahedral, so pointing up or pointing down doesn't matter which way we go. But one more bond is going to be in the plane, and then we have a wedge and a dash for our other 2 hydrogens. So there's our CH3, our oxygen, our ring, and our carbon. And how about this second carbon? Where are we going to draw that? What's our geometry for sp? Every single atom you draw, you have to think about where it goes before you draw it. So it's sp, so that means it's linear. So our first bond is here. Where's the second bond? Straight up. Straight up. So that's the shape of our molecule. And the hydrogen, straight up again. So sometimes you end up running off the page or hitting other molecules if you don't plan correctly, but that's okay. So how do we draw our triple bond? 2 pi bonds means we need 2 sets of p orbitals. So here's our first set perpendicular to the sp. And then the second set we can make it parallel to these other guys, wedge and dash, wedge and dash. And there's our triple bond. Okay, so here's our molecule. I think I lost a... I didn't have something attached down here. There we go. So here's our benzene ring. Notice benzene ring is totally flat because all the atoms are sp2 hybridized. And we have the triple bond extending from there, so that's going to go straight up. And then imagine this a different color being oxygen, these just lone pairs, and then we have our tetrahedral methyl group. Okay, so working with the models really helps confirm the fact that you've drawn a reasonable structure. If you have some strange bond angles or something that's not right, you're not going to be able to get your model to fit it. So that's a really great way of practicing it. So we'll make sure we have a complete Lewis structure, assign our hybridization, and do our geometry atom by atom as we build up a more complex molecule. All right, good luck with your drawings.